Our next speaker is a technology and organizational change specialist who has been coaching, coding, and consulting for almost 30 years. That's really a long time. The originator of behavior-driven development and deliberate discovery. Please give a warm welcome to Daniel North. Today, Daniel will try to show us a better alternative to well-known solid design principles, which in the eyes of many engineers can be a little bit outdated. The title of the talk is CUPID, for joyful coding. Daniel, you have our undivided attention.
Fantastic. Very excited to be here. Hello, everybody. I've got to say, just at the top of this, I'm really excited about the format of this talk. So there's a 15-minute slot, but it's a 30-minute talk with 20 minutes for questions, which I think is brilliant. Usually there's like a talk and then like a couple of questions squeezed in at the end. So I'm very excited. As you can tell by my voice, I have a horrible cold at the moment. So hopefully I'll still be able to talk through that. Let's see what happens. So CUPID then, thanks for that introduction. That's exactly right. So a few years ago, there's a wonderful word, iconoclast. An iconoclast is someone who breaks down ancient religious symbols, and so an iconoclast is someone who rails against the status quo. And I gave a very short, it's a 5-minute talk, an iconoclastic 5-minute talk about solid and about how I wasn't a fan of solid. And it was supposed to be a fun talk, and it was a silly throwaway talk, and then I made a very silly mistake. I put the slides online, and then a whole load of people calling themselves software craftsmen came after me with pitchforks, and we got very cross that I dared to challenge the holy writ of solid. So anyway, so a few years later, beginning of this year, someone challenged me and they said, okay, so you're clearly not a fan of solid, or you think, well, the actual language I use is this: it's neither necessary nor sufficient. So if you look at each of the 5 principles of solid, single responsibility, open closed, Liskov substitutability, the I is, I don't even remember, D is dependency inversion, interface segregation, there you go, that's the I. As the introduction said, I've been writing software for 30 years, and I've never sat there and said to myself, is the substitutability principle being violated? That's not how I think about software. So early this year, someone challenged me and they said, okay, so you're not a fan of solid, what would you propose instead? And I thought that was a really brilliant question, because it raises the second question, which is, or the deeper question, which is, are there any kind of principles or rules or whatever it is that would underlie all good software? Are there any universal kind of properties of software? And that got me thinking. So before I get into my response to that, I just want to think about software for a minute. So who are we writing code for? So one of the most, I think, impactful books that I read, certainly one of the books that had the biggest impact on the way I think about software, was Refactoring by Martin Fowler, published in 1996. I think I probably read it a couple of years after that, late 90s. And in it, in the early chapters, he says this. He says, any fool can write code that a computer can understand. Good programmers write code that humans can understand. And that really landed for me. That was a really profound moment. I was like, wow, I'm not writing instructions to a computer. I'm writing to a fellow human being what I want a computer to do. And that changes a lot of things about how you think about software. And I came back to this phrase again and again. And I said, I keep getting stuck on this word understand. Understand seems like a pretty low bar to me. Can we do better than understand? Like, okay, so you can understand Morse code, okay, but it's not the ideal way to do reading, okay. So can we do better than understand? Around the same time in the late 90s, Dick Gabriel, computing pioneer, he talked about the habitability, and he says, he's writing a series of essays, and in one of the essays he says this: habitability is the characteristic of source code that enables, and he says a whole bunch of different types of people, to understand its construction and intentions and to change it comfortably and confidently. And I thought about those words, comfortably and confidently, and I just went, that is what I'm trying to describe. How often, and this is to anyone who's a long way into their career, so more than say 10 or 15 years into your career, how many times over that 10 or 15 years have you worked in a code base where you genuinely felt comfortable and confident making changes? And to folks earlier in your career, maybe 1 or 2 years out of college, or if you didn't go to college, 1 or 2 years in, in programming as a career, have you had that experience yet? Have you worked in a code base where you went, I get this, it all makes sense, I can manipulate this code really easily? Habitability, says Dick Gabriel, makes a place livable like home. And I was like, yeah, you spend a lot of your working hours as a programmer, you spend a lot of your waking hours living in code, living in various different code bases. So do you want a really messy home? Do you want a really tidy home? Do you want a home where you know things are? Do you want a home where you're afraid to turn a light switch in case you get electrocuted, or that the switches don't do the things that they're supposed to? That's not a great home to be in. So I like habitability, and I thought, well, let's go past. So we've got understandable. What's past habitable? What might be past there? And I was thinking about joyful. What about joyful code? What about code where when you're in that code, it's joyful to work with it? You smile. You go, oh, brilliant. I get to work on the pricing code base. I get to work on the customer order code base today. And I've been in there before, and it is just so nice to work with. Everything's there. I can make changes confidently. It's joyful. It makes me smile. I know I'm going to do good work there. I know I'm going to leave it tidy because it's easy to leave it tidy. I know I'm going to go home at the end of today having done a solid, happy, fulfilling day's work. Okay, so that's great, but can we describe what makes it joyful, right? And what kind of properties does joyful code have? Are there any universals here? Now, folks who know me will know I'm a bit like this. I'm very, very deliberate about my choice of language. Behavior-driven development was me being very deliberate about the language of test-driven development. Test-driven development, to me, the word test in there is massively confusing and has led to literally decades of misunderstanding of what is a very powerful software design technique. So that's where behavior-driven development came from. I'm talking about properties very deliberately rather than principles. Okay, so let's take a look at this. What do I mean by properties and principles? Principles are rules. Rules or guidelines. They define conditions or boundaries. Okay, so you're either inside the circle or you're outside the circle. You have code that conforms to single responsibility or it doesn't. And it leads to some really interesting behaviors. I've seen, and also I've been hearing lots of anecdotal stories, giving this talk a number of times. People are saying to me, do you know, one of the things I see with the solid principles, is you get particularly young men, young males straight out of college, who kind of nominate themselves as the solid police, as the principles police. And they're walking around going, that code violates the single responsibility principle. And that code violates the interface segregation principle. And you're like, take a breath. Let's get some work done here. So conversely, properties are qualities. They're characteristics. So they define a center. And your code can be closer or further from that center. It's never like, outwards, in exile. And there's never like a best kind of thing. It's a scale, right? So properties are qualities or characteristics of software. They define a goal. And so your code is closer to or further from the center. Now, slight warning, I'm going to get a bit meta here. I want to talk about properties for properties, right? If we're going to have properties to describe software, what kinds of things, what characteristics would I want those properties to have? Well, I came up with 3. The first is this: they need to be practical. So if we're going to describe properties for joyful software, then those properties need to be easy to articulate, easy to describe to someone, easy to assess. To what extent does this code, demonstrate that property? And easy to adopt. If I decide that I like Daniel's properties and I want to apply them to this code base, how could I go about? Where do I start? Okay, if a property doesn't have those characteristics, it's not very useful, right? If it's hard to describe, then people are just going to be scratching their heads and they're going to give up. If it's hard to tell whether my thing fits your description or not, again, I'm probably not going to play. And even if those first two things are true and it's hard to get started with your thing, I'm probably not going to get started. I've got work to do. I'm busy, okay? So the next thing is this. It needs to be human. So a lot of particularly the solid principles, but also there are many other examples. Properties tend to be about code. So static analysis is about code complexity. Function point analysis, these kind of things. These are about characteristics of code. What I want is characteristics from a human perspective. So as a person interacting with that code, let's talk about properties from that perspective. And the third thing is I don't want them to be like simple one-dimensional, box ticking. So when you're a beginner, sure, they should be guidance, right? They should be easy, as I said, accessible, easy to articulate, easy to assess. As you become a more experienced developer, maybe a decade, a couple of decades, a bunch of experience, and again with the caveat from the pragmatic programmers that 1 year, the same year 10 times is not the same as 10 years experience. So as you become more experienced, as you've been around a bit, you can look back at the same properties and say, yes, I can see layers of texture there, I can see layers of nuance there. And so we can start kind of challenging ourselves into more deep thinking. And so then here's the reveal then. So CUPID was the acronym I came up with. To be technically accurate, it's a backronym. In other words, I started with a word and then I made some things make that word. So solid acronym is a genuine acronym. It's the first 5 of many of Robert Martin's principles of software. And Mike Feathers happened to notice that the first 5 of them, if you put them in a particular order, spelt solid. I went the other way. So it was February when I was challenged with this. And so it was Valentine's, and I thought Cupid. Cupid is about joy and love rather than solid being kind of big macho thing. So I was deliberately kind of having some fun with that. So here are my 5 properties of what I think joyful code has, and I'm going to spend a few minutes going into each of them. So the first thing is this. I want code that's composable. I want code that plays well with others. The second thing is the Unix philosophy. Now, Unix and I grew up together. We're both born about 4 months apart. So I know how old Unix is. It's about 4 months older than me. So it's in its early 50s now. It's doing okay. And it's basically taken over the world. During the 90s, there were what's called the Unix wars, where every single hardware vendor had their own Unix. IBM had one, HP had one, Sun had one. The Santa Cruz operation, SCO, was on Intel. I'm sure there are many others that I'm forgetting, but there were loads of RISC ones as well. So Digital DEC Corporation. So each of these vendors had their own Unix. Eventually, this tiny little open source project that started in the mid-90s called Linux by this unknown Finnish student ended up basically taking over the world, and Unix is everywhere in the form of Linux. The Unix philosophy, the thing that has made Unix stand the test of time is this. Everything in Unix, every command in Unix does one thing well. The system libraries have the same property. They do one thing well. And that, along with composability, you could take over the world, right? So, and again, the whole point of these properties is they all play nice with each other. Third thing is predictable. I want code that's predictable. It does what I expect. And I think of predictable as a generalization of testable. And I'll explain what I mean by that in a minute too. The I of CUPID is idiomatic. I want code that feels natural if you understand how code is written. If you're a Clojure programmer, you're looking at Clojure, it should feel like anyone else's Clojure. If you're a Python programmer, it should feel like other people's Python. And again, we'll see what that means in a minute. And finally, domain-based. So I want code that is domain-based, not just in language, a domain-driven design kind of language, but in structure. And that, to me, is one of my big bugbears, and I'll explain that again in a moment. So let's dig into each of these. In the top corner there's a handy guide that says which letter we're on. So we're currently on C of CUPID. Composable, what does that mean? Code that's easy to use gets used. It's a bit of a truism, right? Code that's easy to use gets used and used and used. There's a lovely quote from one of the folks behind Spring. And he said, reuse is overrated. Design for use, which I just thought was a lovely thing to bear in mind. Yeah, we need to be reusable. No, first of all, it needs to be usable. If you make it usable well, it will get reused. So code that's easy to use gets used and used and used. What does easy to use mean? It means it has a small surface area, right? The power to weight ratio. I want little things that do a lot. So a small surface area, there's less to learn, there's less to go wrong, and there's less to conflict with other things. If I have lots of APIs and they'll have loads of things they can do, suddenly there's like dozens and dozens of different ways to do the same thing. And in that mess is where we're going to get fragmentation, where we're going to get confusion, where we're going to get all kinds of very subtle bugs. So small surface area, tiny little APIs. And I want intention revealing names and purposes. It's very likely, and certainly very common on code bases I've worked on, that the names of things change over time as we learn. It may be that its purpose changes over time, but often its purpose doesn't change. We just didn't name it very well in the first place. And so a customer account might become a checking account as we add more different types of account. And there's a savings account and a checking account, and maybe a retail banking application. And then we end up with several savings accounts. So now savings account is no longer the correct term, and so on. And so the thing, the data construct we have, or the functionality we have, does the same thing, but the name is going to evolve as we understand the domain better. Intention revealing names and purposes mean that it's easy for me to find the thing. So discoverability is a big deal. Remember, code that's easy to use gets used, and code that's easy to find is generally going to be more likely to be used than code that's hard to find. Don't give your new library or product a name that's incredibly hard to Google, right? Calling Go was a really dumb idea, some might say, but then the name Golang sort of became the hook for Go, and so generally you'll Google for Golang and it's searchable at least. Easy to discover, easy to evaluate. Okay, so what that means is this: I might be about to use your code. Thank you so much for putting it out there, making it available. I love you for that. I want to know whether I want to know whether your thing solves my problem. And if you make it easy to evaluate, one of my favorite hooks for this is the 2-minute and 10-minute tutorial. So anything you open source, but also internal products and internal APIs that you share with your colleagues, I should be able to find this thing, and there's a 2-minute tutorial. I can find out straight away, is this useful for me? Is this a thing I need? And I can understand how it works. And then a 10-minute tutorial, take it for a drive, understand a bit more about it. So based on those two things, I should be able to come away fairly confident that I know whether or not this thing is going to solve my problem. Or more importantly, I'm going to be confident that it won't, and I can move on. So imagine everything you tried to evaluate came with that 2-minute tutorial. So you know you're going to invest at most 2 minutes deciding that, kissing the frogs, right? You're going to spend at most 2 minutes trying out each thing of discovering it's wrong. That suddenly makes the cost of trying things very low, which means you try lots of things, which means you're more likely to end up with a suitable thing. And minimal dependencies. Yes, NPM, I'm looking at you. Yes, Maven, I'm looking at you, right? There's Joe Armstrong, the late wonderful Joe Armstrong, who invented the Erlang programming language, along with a whole bunch of other really awesome things. He had this quote about object-oriented programming, and particularly object-oriented runtimes. He says, you wanted a banana, but you got the whole damn gorilla, right? Something with minimal dependencies means that I'm likely to use it. So I used to, and I've done a full 180 on this. I used to be, if it exists, go get it. If it exists, there is no point reinventing it. Now I'm totally the opposite. If I'm going to bring in a dependency, it really needs to earn its place in my dependency graph. Okay. If I can write in a few lines of code what that dependency does, I'll write the few lines of code every time. And that's not a not invented here mindset. That is a minimizing the enormous risk of bringing in a huge surface area of something with loads of dependencies. Okay, so that's our composable then. Let's take a look at Unix philosophy. This is Ken Thompson and friends back in the, like I say, in the late 60s, early 70s. They said this, they said, make each program do one thing well, and only one thing. The example I like to use is ls, right? The ls command. Ls is lists files. What ls doesn't do is look at files, right? That only occurred to me when I was thinking about this recently. Ls doesn't know about files. Ls doesn't know anything about getting files. There is a system command, a library command called stat, and related commands, lstat and fstat, but stat is the Unix C system command that looks at file details, looks at directories, looks at special devices, and gives you a structure back, a stat structure that tells you about that thing. ls just tabulates those structures. So ls, even though we think of ls as listing file details, that's all it's doing. It's just tabulating the output. That's all that ls does. It does it in a squillion different ways, in every possible way, including forwards, backwards, by size, by date, by owner, by special attributes, by all kinds of crazy stuff. But it doesn't know how to get that. It says, stat, tell me about all these files. I'm going to make them look good for this person who wants to know about them. Doesn't inspect files. So once you've got something that does one thing well, one and only one thing, so that's the other thing as well. I don't need to look anywhere else to list files, right? ls does all that. And then what that means, along with composability, which in Unix terms, composability is captured by this phrase: expect the output of every program to become the input to another. So they invented the pipe symbol. I think that was Ken Thompson again, invented the pipe symbol. And the pipe symbol says the output of this thing becomes the input of this thing. So cat says, give me the contents of a file. grep filters the contents of the file. Sed then transforms various parts of the contents of that file. Sort then takes all of that output and puts it in some kind of sorted state by numerically or alphabetically or whatever it might be. And unique removes duplicates. So with a bunch of commands like that and a handful of others, there's practically no manipulation on text that you can't do. And most of those are very, very small. So sed is a little bit of an outlier there, and awk is another one where they're actually languages posing as commands. But even then, the purpose of that language, the purpose of awk is match things and do stuff, right? Purpose of sed is find patterns and transform them. So they still only have one responsibility. They still only do one thing. Isn't this the same as SRP? No, it's not. This, remember I said I'm looking at properties from a human perspective. The Unix philosophy is from a human perspective. This thing does one thing well, okay? SRP talks about the code itself, says the code has only one and only one reason to change, which I dispute anyway, but that's a whole other story. P then, the P of CUPID is about predictability. Predictability is this: it behaves as expected with no surprises. So Kent Beck has this lovely phrase, passes all the tests, which is true, but I'm kind of broadening that, saying even when there's no tests. I've been in code bases that had zero test coverage or zero automated tests, and those code bases were a joy to navigate. They were a joy to work in because the code was so well structured and obvious and simple, and I could make sense of it and make changes confidently. Conversely, I've been in fully test-driven code bases that were an absolute cow, because TDD is brilliant at designing the small. TDD does not have an opinion about architectural consistency, architectural cohesion. You could go down one set of rat holes over here, another set of rat holes over here with TDD, and none of these parts make sense when you stand back. Okay, so you need that cohesion as well. Deterministic is another part of predictable, which is that it does the same thing every time. Okay, when I run it, it does the thing. When I run it again, it does the same thing. And this is about operating characteristics. This might be about memory usage, CPU usage, I/O. So I can know when there's going to be spikes. I can know when things are going to suddenly blow up or not. And this comes with observability. And this is observability in the charity majors, mipsy-tipsy technical sense, right? Which is internal states can be inferred entirely by outputs. So what that means is just by looking at what's happening with a system, I can tell you what its internal health is. And it's really hard to retrofit that. Okay, you design for observability or you bolt on monitoring, right? One of these is much more deterministic when you get into production. So instrumentation, telemetry are part of the story, but again, this goes right into your design and architecture aesthetics as well. This is where we start to get, I think, more kind of linguistic, if you like. Language idioms. If you're writing in Ruby, use Ruby idioms. If you're writing in, I don't know, Go, use Go idioms. Go is a fantastic example. It comes with a program called Go format that makes all your code look like everyone else's code who writes Go. And I'm pretty sure when they decided on the language, on the layout syntax rules for Go format, they decided they were going to offend everybody. There is nothing like when you read any of this, there's something in there that's going to offend you. They use tabs for indentation, which is illegal in some states, right? And the curly braces, I'm not going to talk about that. But when you have multiple assignments, they line up all the equal signs by just using space padding. And that I love that because I'm a bit of a nerd. I do that. And so there's stuff in there I like and stuff in there I don't like. The important thing is it doesn't matter. The important thing is that all Go code looks the same. There are some languages like Java, like Scala, that are totally unopinionated. You can write any kind of code you like in them, right? Which is, it's quite a nice pull. Come in and write, if you want to write functional Scala, you can do that. If you want to write OO Scala, you can do that. If you want to write, procedural Scala, go nuts. What it means is that if you have a team with 5 people writing Scala, you'll have at least 6 or 7 different dialects of Scala in the same code base. And that's cognitive load. That hurts your brain. So you want to use standard features, standard constructs, standard libraries and frameworks and tools. And so that when you come there, all you need to be is experienced in that language or in that language's ecosystem. And this thing should feel familiar to you. And not just the language idioms, the local idioms. How do we do things here, right? The house style. So in a particular code base you're in a particular team you're in, there should be designs, there'll be a style, right? And it may not be documented, right? The design standards may not exist. They're just de facto. They're just what's there. But I love this Sam Newman quote. He doesn't remember saying it, but I remember him saying it. He said, "I'd rather things were consistently wrong than inconsistently anything." So in other words, if you're going to have some weird house style, everyone adopts that weird house style. And it just means that there's a load of thinking we don't have to do. And then we can shift that towards a better style. But having it all fragmented in the first place is a much harder place to start from. And, again, it's fairly obvious, but I'll spell it out. You can only write idiomatic code if you learn the idioms. You can write. So I did this when I first started coding in Python. From Java, I was writing Java in Python. I had objects and classes and all sorts all over the place. It looked like Java without the curly braces. Once I understood how Python did namespacing with packages and modules and the beauty and joy of the language that is Python, and it is a joyful language, I suddenly stripped away most of the cruft that I put in there because I'm a Java programmer and ended up with Python, and it's lovely, right? So learn the idioms. And finally, I just want to talk a little bit about domain-based. So what does this mean? Well, obviously, using the domain language. You want to code in the language of the domain. My contribution to Kevin and Henry's book, 97 Things Every Programmer Should Know, was a contribution called Code in the Language of the Domain, which gives an example of some very code-like stuff, like it's a map of ints of maps of ints to ints or something like this. And it ends up being something about trading rules. And just by really simply restructuring it slightly and giving it good names, it became obvious that it was about trading rules. And you may have come across it because typically when Kevlin talks about the 97 Things series, he uses a handful of examples, and mine is one of the examples he tends to use. So code in the language of the domain, and remember there's multiple domains. So there's the, as well as if I'm doing a healthcare app, there's the domain of patients and patient records and patient record data. There's also the domain of persistence. There's the domain of regulatory. There's the domain of data transfer. There's the domain of system events. And so there will be a number of different domains all working together. So that language should pervade all of your code. But also, and please, if there's one thing you take away from this talk, make it be this thing. Structure your code like the domain, okay? Generally, I see, and Rails was the biggest offender for this, but only because it was the most popular framework for a long time, was that instead of having, in my patient record system, say, instead of having patient records, and there might be some patient stuff and some hospital visit stuff and some whatever else, and various different subdomains, bounded context and domain-driven language, where my code lives. There's a models folder and a views folder and a controllers folder. So if I'm doing something with doctor information, then I need to look in 5 different places. And of course, then helpers and utils and all the other things that end up being stuck on there. So structure your code source files in a domain-driven way as well. And it just means that when you are working, you're likely to be working in one place. And finally, use domain boundaries. And I'll just mention that Simon Brown's C4 modeling, a wonderful, wonderful way of visualizing software and visualizing architecture. He talks about components of, containers of deployability, not Docker containers, generally the idea of a single deployable unit. If your deployable units are bounded contexts or are within bounded context, then it means that you can make deployment decisions that are very aligned with the way the business works, okay? So recapping then, composable, things that play well with others, Unix philosophy, do one thing, do it well, predictable, testable, does what you expect, has operating characteristics you expect, idiomatic, it feels natural to someone who has experience of that technology, domain-based both in language and in structure of the code. And if you get those 5 properties in code, then I think you're likely to be working with joyful code. So thank you very much. And with that, I guess we're open for questions.
Thank you very much, Daniel, for this talk. Personally, I was never a huge fan of solid principle. So whenever I hear of any alternative, I'm just all ears. And I see that we also have very positive comments on the chat. There are some likes about the great talk about the properties over principles. Love it. The statement was in the chat. And we have also a few questions because obviously we had few engineers during this talk. If you have some questions, this is the request to audience. In the meantime, feel free to still post them to the chat. And in the meantime, we'll go with few others questions we have here. So the first one then, I think this one is kind of tricky. Is there anything preventing us from using CUPID along with Solid? Why choose only one?
No. No, there's nothing preventing you tying yourself in as many knots as you want. Okay, so whenever I'm looking at anything like this, and like I say, this was a request. Someone said to me, if you were going to come up with some of these kind of guidelines, what would they be? And I looked at it and I said they wouldn't be principle based. That's the first thing. Is these are characteristics of that code. All code possesses to a more or lesser degree, greater or lesser degree. So what I wanted was, this is the as simple as possible, but no simpler. So as few as possible characteristics, but no fewer. So if I take any of these away, I can give you horror stories from my career where code didn't possess these things. Okay. But is there anything else I'd add? I'm sure there is. I'm sure we could have Cupid's bow. There we go. Because let's just make some more backronyms. Then I need an S, a D, an O, and a W. There we go. But yes, I could add a bunch more, but there's a diminishing return here. And you could add all of Solid. And in fact, if you go and look at the clean code work, Solid is just the first 5 of like hundreds. There's loads and loads of there's principles for everything. And no human being is going to carry all those around in their back pocket. Okay. If you want to write good code, if you want, and this isn't just about the craftsmanship nerding over code thing. This isn't code for code's sake. This is right back to Martin's quote from the very top of the talk, right? We're looking at code for humans. We're writing code for humans. If we're writing code for humans, okay, let's write code that is in small composable pieces, because that's just being nicer to each other and nicer to ourselves. Let's write code that does one really obvious thing, you know. And since it's taken on the role of doing that one obvious thing, let's do it so that you don't then need to go and get the same thing in 5 other ways. One example would be if you're in the Node.js or the JavaScript world, the proliferation of build tools. You know, grunt and gulp and slurp and swallow, and I'm just making them up now, right? I don't know. There's just a huge amount of just tools and tools and tools. And each tool is like someone looking at the tools that are there and going, that doesn't quite do what I want it to do. And I'm going to go, and you're like, wow, you know, Make has been around since the 70s, right? And is still by far the best build tool that I know. Mm. You know, I'll use Make for JavaScript, I'll use Make for Python, I'll use Make for Java, I'll use Make for practically anything, because it solves that problem brilliantly. It says, what's your target? What are you trying to build? What are the rules to build it? Let me figure out how to chain together all of the sequence of actions that needs to build it. Do one thing well. Don't surprise me. Don't surprise me unpleasantly. You know, I want to write code that you don't have to pretend to be me to understand. You can be you and still read my code, because I wrote it like you would write it, because I wrote it like anyone using this technology would write it. That's idiomatic. And finally, domain-based. If you understand finance, or if you understand healthcare, or if you understand aeronautics, or whatever domain we're in, you should be able to look at my code and go, oh yeah, I can see what that's doing. Mm-hmm. And if you just get those 5, if you take any of those away, your life's going to be harder, I suspect. If you pile on some more stuff, sure, go nuts. But I don't really see the value of those diminishing returns.
Okay, thanks a lot for this answer. That really makes sense. But then there we have also another question, which is also very interesting because it touches the point of engineer. So the question is that not a problem of bad engineers? Bad engineers will write bad software with or without solid or CUPID principles.
So there are no bad engineers. Oh, that's a controversial statement.
Yeah,
let me reframe that. In 30 years, I'm going to lean on my 30 years a bit here. I've been writing software in many different technologies, in many different contexts, in many different domains for a bunch of time. In that 30 years, I've come across, and I can tell you them, but I won't, two genuinely bad engineers. Right? That's a pretty low hit rate. Either I've been very lucky, or there aren't. But now I've come across eye-watering amounts of bad engineering, eye-watering amounts of bad software. But the software wasn't written by bad engineers. The software was written by human beings in impossible circumstances. So an awful lot of this is about how do you create the environment for good software to emerge. And we've heard Conway's law a number of times today, and I'm sure we'll hear it a number of times tomorrow too. It's just one of those perennial topics. If you structure the organization around the problems you're trying to solve, you'll solve those problems better, right? That's basically what Melvin Conway's saying. But this is not a problem of bad engineering. This is a problem of us setting ourselves up to fail, inevitably failing, and then blaming the people who were there. Okay. So what we can do instead is set ourselves up to succeed, and the same people we're labeling bad engineers will pick up these habits, and guess what? You'll get good software. You know, and so if you take kids out of high school or out of college or whatever and say, right, small composable units, do one thing well, make it predictable, just carry those around in your back pocket, right? Put it on a little poster, a little postcard. I do not have merchandise, certainly not yet, but put it on a little card, right? Stick it on your screen. Straight out of school, I can look at something and go, this is doing a whole bunch of different things quite badly, right? Daniel would be cross with this. I don't want to make Daniel sad, yeah? Or, you know, this sort of works, but it's really intermittent and it keeps failing. That's not predictable. How can I make it more predictable? Let me read up on TDD. Oh, that looks like quite useful. What about BDD? Oh, that looks useful. I'm going to start learning some techniques that allow me to make more predictable code. So if I start trying to adopt these properties for my code, I'm going to write better software. Software programming is behavioral. When you talk about bad engineers, that's an identity statement. You are a bad engineer. No, you may do bad engineering, but that's about the context you're in. So if we can make the context better, we're going to get better engineering. That's a great question.
That was very interesting point of view and very interesting answer from a little bit different angle. So thank you very much for it. The first question was about adding more principles. And then the third question is about having less principles. Let me read it. So Daniel, why not go minimalism with the only one principle, the universal one that applies to all code? The only code that must be changed is code that is wrong. So I assume that the person would like to stay only with one principle and nothing more. How do you view that?
So, okay, this is fun. I started with one principle. So when I did, so the original talk, if you want to Google it, is, or DuckDuckGo it, other search engines are available, is called Why Every Element of Solid is Wrong, which is deliberately controversial talk. Title, it's it's a 5-minute lightning talk with 20 slides, 15 seconds, that kind of thing. So it's deliberately controversial. And my original thought with the talk was, for each of the 5 principles, I kind of introduce the principle, say why I disagree with it, say what I do instead. And I thought that would be a nice little framing for 20 slides. And what I found was that as I was doing each of the 5 principles, that the what I do instead kept being the same thing, which is write simple code. Okay. Now, obviously, that is a very layered assertion, right? Write simple code is a very layered statement. So I need to define simple. And so I define simple as code that fits in my head. And then you go, well, everyone's got different heads. So how can you have that as a principle? And I say, no, okay, I'll tell you whose head. It should fit in the head of someone who understands the technology you're using reasonably well, who understands the domain problem you're solving reasonably well. So let's take that person. If what the code you've written fits in that person's head, it's fine. It's when it doesn't, when you've overcomplicated the domain from their perspective. Like, I understand how trade algorithms work, and I don't get what this code's doing, right? Then that doesn't fit in their head. Or I'm an experienced C++ programmer, and I'm looking at your code, and it's just all over the place. Okay, that's a really good signal, yeah? And so someone who understands basically the solution space and the problem space reasonably well, they don't have to be a guru, looking at that code should go, yeah, I get that. And that really is the only heuristic in town. So that, if you take that as write simple code, that is single responsibility, open, close, they all collapse into the same space. And so then I got a lot of pushback of, oh, write simple code is too abstract. And that's where CUPID came from. What if I came up with an actionable version of write simple code? And it's these 5 things, which, obviously gamed to make the word CUPID.
Okay, thank you very much for this answer. That really makes sense. So, Daniel, I think we run out of questions, at least for now, but definitely there is more room for discussion on a dedicated channel after this session. So
fantastic. I will be in that channel, so I'll happily take questions on Slack.
Amazing. So I would like to thank you very much for your amazing talk and for helping me to finding some alternative to solid principle, which I personally really like. So thanks a lot for that. And yeah, this is also a request to our audience that we would like to kindly ask you for your feedback. And there is obviously a place for that. So feel free to leave it and not forget it about it.